At this point, I think I know more about manufacturing than anyone currently alive on Earth.
Každý už videl záber pasu automatizovanej výroby. Ako sa pri úplne jednoduchom produkte, ako obyčajná fľaška, jeho výrobný pás podobá viac na čreva mimozemskej lode, ako na finálny produkt. Tieto sofistikované systémy niekto navrhol a roztočil na šialené otáčky, aby mohlo byť samozrejmosťou, že ak niečo potrebuješ, môžeš si to bez myšlienky strhnúť z poličky rovno do košíka. Teda väčšinou s myšlienkou, ako to použiješ doma, než na to, čo všetko sa muselo stať, aby sa to na tú poličku dostalo. Aké je to s produktom, ktorý sa skladá z 10 000 súčiastok, sa dozvieš z komentov týpka, ktorý niekoľko rokov spal v továrniach a vývoja jeho myšlienok ohľadom veľkovýroby za posledných 10 rokov.
Our time is spent trying to figure out how to make more cars. And the things that prevent us from doing that are supplier parts, essentially. We've got like 90% of our suppliers are able to ramp up, and 5% have some difficulty, and 4% have a lot of difficulty, and 1% just can't. And so we've got to replace those or in-source those items, because you can't give people a car that's 99% complete, unfortunately, and there's several thousand unique parts in the car. We had some trouble attracting the A-team from suppliers. They thought we wouldn't be around long term, and we had that issue where IHS had predicted that Tesla would only ever sell 3,000 cars lifetime.
Tesla v tom roku dodala cez 22 000 vozidiel.
Many of our suppliers had taken the IHS number, and so they didn't tool up for the production that we actually experienced. Mm-hmm. And so they were scrambling to make up for it. They just didn't believe it, so it takes some time to tool up and do it. And then some suppliers, just a small number, they're just not set up for volume production, so we've got to switch them out or insource it.
Nasledujúcich 10 rokov Tesla ťahala stále väčšie množstvo výroby pod vlastnú strechu.
Very often people think of manufacturing as kind of just some rote process of making copies, which actually it isn't. Manufacturing is building the machine that makes the machine. And if you think the machine is important, well, building the machine that makes the machine is also extremely important. And more often than not, what I found is the manufacturing is harder than the original product. Like, for example, at Tesla, we can make like one of a car very easily, but to make thousands of a car with high reliability and quality and where the cost is affordable is extremely hard. I'd say maybe 10 times harder than just making one prototype, but maybe more. And then at SpaceX also, it may be approaching an order of magnitude harder to manufacture rockets and launch a lot of them than to design one in the first place.
But people don't quite appreciate how hard it is to manufacture something. It is really hard. Okay? I have great respect for people who manufacture large numbers of complex objects.
2014 31 000 vozidiel.
Most of our focus is actually on production growth as opposed to demand generation. And we're more than, in terms of our weekly rate, we doubled it year over year. It's pretty hard for a manufacturing company with a complex supply chain to grow by almost 100% in annualized production.
2015 50 000.
So, just talking about the future.
most important point I want to make is that we've realized that the true problem, the true difficulty, and where the greatest potential is building the machine that makes the machine. In other words, building the factory. I actually think that the potential for improvement in the machine that makes the machine is a factor of 10 greater than the potential on the car side. I think maybe more than a factor of 10. You know, running production personally at a detailed level. You know, I do my favorite thing, which is apply physics first principles. When you think of a production facility on a fundamental level, for a given size of factory, the output is going to be volume times density times velocity. What is the density of useful to non-useful volume? It's crazy low. It's like 2 or 3%. If you look at volumetrically, not just on a planar level, but volumetrically, it's literally 2 or 3%. And then you say like velocity, and like you also think of it like the design of a modern system on a chip or a computer. And you say if you look at say the complexity of the board, how close together the line traces are, and how focused things are on clock speed and data transfer from RAM to say a solid-state disk or the internal CPU cache. It's like, wow, there's crazy potential for improvement here. I think at least an order of magnitude potential for improvement on production. Yeah, so we're basically going to design a factory like you design an advanced computer.
2016 76 000.
The thing that's going to be the major challenge for us over the next 6 to 9 months is how do we build a huge number of cars? And frankly, we're going to be in production hell. Welcome. Welcome to production hell. As the saying goes, if you're going through hell, keep going. There are 10,000 unique parts in a Model 3, and these are coming from all over the world. About 2/3 come from North America, and about 1/3 from the rest of the world. But as you can see with this chart, which looks like we're being shot with ICBMs, when you have 10,000 unique items in a vehicle or any object, any one of them can slow down the production process. So the production rate will move as fast as the slowest and least luckiest component in the whole mix. So we've got giant factory making battery packs and powertrains, giant factory making cars, and giant supply chain. And so all of those have to work together in cadence in order to get to our initial target of 5,000 cars a week, and then hopefully by the end of next year towards 10,000 cars a week.
2017 100 000.
I would say like 2018 is probably felt like aging 5 years in one. Honestly, it was really intense.
V 2018 Tesla dodala cez 245.
The difficulty and value of manufacturing is underappreciated. It's maybe 100 times harder to design the manufacturing system than to design the vehicle itself. The issue is definitely not coming up with a car design. It is absolutely all about building the production system. You know, when we acquired the Fremont factory, people sort of thought, oh, you've got a car factory. Now, if you have a car, they sort of think if you have a car factory, you can just make any car. It's like, no, that's like saying you've got a box. That box can have anything you want in it. No, only if you make the thing in the box. And it took an enormous amount of effort by a very talented team to actually turn essentially what looked like a derelict warehouse into a working car factory.
Tesla kúpila existujúcu továreň za drobné. Každá nasledujúca továreň je jej vlastným dizajnom a najnovšou generáciou výrobných liniek. Tento fakt bude platiť aj pre všetky budúce továrne Tesly.
Then the challenge is like, okay, if we create a car factory, where the heck are the batteries and electric motors and power electronics going to come from? Just do the basic math. We need 50 gigawatt hours. So we better have a real big factory, or there's no way. So it's kind of difficult to appreciate scale, but again, it's work of a tremendously talented team working like crazy, like tens of thousands of people to produce this factory. And today it produces more lithium ion than the rest of the world combined. So.
There's actually not enough appreciation for the difficulty of manufacturing. Manufacturing is insanely difficult. But a lot of people I talk to think if you just have the right design, you can instantly make as much of that thing as the world wants. This is not true. It's extremely hard to design a new manufacturing system for new technology. Audi's having major problems manufacturing the e-tron, and they are extremely good at manufacturing. And if they're having problems, what about others?
367.
At this point, I think designing a rocket is trivial, just trivial. There's tons of books you read them, you can understand equations, you can design a rocket. It's real easy. Yeah. If you say two-stage, 2% of your liftoff mass to orbit, just to design something like that, piece of cake. The next step is you want to make even one of those things. Okay, now making even one of those things and getting it to orbit is hard. The making of a production line that builds and launches many is extremely hard. But by building a machine that builds a machine, I mean creating the production system. The hard part is making it and making lots of them and launching frequently.
We have liftoff.
Flying truck.
Starship vehicle. Tower clear. We're into pitch over. The thrust of the Saturn V heading to
space. The thing to bear in mind with production is, for those who've never done production, they just don't understand how insanely hard production is. I want to really be very, very emphatic here. Prototypes are trivial. They're child's play. Production is hard. It is very hard. Now you say production at large scale with high reliability and low cost, insanely difficult. But what Tesla achieved on the automotive side was not to create an electric car. The truly profound thing on the car side is that Tesla was the first American car company to achieve volume production of a car in 100 years and not go bankrupt. So myself and many others at Tesla had to basically have several aneurysms to get this done. It was so hard. You have no idea. Anyway, and the thing about making a large, complex manufactured object is, let's say you have 10,000 unique items. If even one of those items is slow, that sets your rate. Just one. We've had production stop because of USB cable. At one point for the Model S, we literally rated every electronics store in the Bay Area. For a few days there, nobody could buy a USB cable in the Bay Area because we went to Baltimore, put them in the car, literally. And there's like hundreds of stories like that. So anyway, that's solving those constraints and a logistics problem that makes World War II look trivial. I'm not kidding. Like, the scale is insane. You know, we're talking millions of cars, massive global supply chain, 30 countries, dozens of regulatory regimes. It's insane.
The absolutely difficult thing, which has not been accomplished by an American car company in 100 years, is reaching volume production without going bankrupt. I lived in the Fremont and Nevada factories for 3 years, fixing that production line, running around like a maniac through every part of that factory, living with the team. Yeah. I slept on the floor so that the team who was going through a hard time could see me on the floor, that they knew that I was not in some ivory tower. Whatever pain they experienced, I had it more. I mean, there wasn't any other way to make it work. There were 3 years of hell. 2017, 18, and 19 were 3 years, the longest period of excruciating pain in my life. There wasn't any other way, and we barely made it, and we were on the ragged edge of bankruptcy the entire time. But it had to be done, or Tesla would be dead. At this point, I think I know more about manufacturing than anyone currently alive on Earth.
Tweet that.
I can tell you how every damn part in that car is made. Got a lot of people excited about the Cybertruck.
No way! No way! What? No way! Let's go! Texas! Woo!
I am too. I've driven the car. It's an amazing product. I do want to emphasize that there will be enormous challenges in reaching volume production with the Cybertruck, and then in making the Cybertruck cash flow positive. This is simply normal for when you've got a product with a lot of new technology, or any new vehicle, brand new vehicle program, but especially one that is as different and advanced as the Cybertruck. You will have problems proportionate to how many new things you're trying to solve at scale. So I just want to emphasize that while I think this is potentially our best product ever, and I think it is our best product ever, it is going to require immense work to reach volume production and be cash flow positive at a price that people can afford. Often people do not understand what is truly hard. That's why I say prototypes are easy, production is hard. The difficulty of going from a prototype to volume production is like 10,000% harder to get to volume production than to make the prototype in the first place. And then it is even harder than that to reach positive cash flow. It's a great product, but financially, it will take, I don't know, a year to 18 months before it is a significant positive cash flow contributor. If you want to do something radical and innovative and something really special like the Cybertruck, it is extremely difficult because there's nothing to copy. You have to invent not just the car, but the way to make the car. So the more uncharted the territory, the less predictable the outcome. I think we'll end up with roughly 250,000 Cybertrucks a year. And I don't think we're going to reach that output rate next year. We'll probably reach it sometime in 2025. I mean, the Cybertruck has a lot of bells and whistles. But 18 months from initial deliveries to reach volume and reach prosperity with an immense, I can't tell you how much, the blood, sweat, and tears level required to achieve that is staggering. I've been through it many times. And then here we go again. You know, Cybertruck is one of those special products that comes along only once in a long while. And special products that come along once in a long while are just incredibly difficult to bring to market, to reach volume, to be prosperous. The manufacturing approach for the high volume small vehicle is revolutionary. We're doing everything possible to simplify that vehicle in order to achieve units per minute level that is unheard of in the auto industry. Enable Optimus to learn how to do things simply by looking. Extremely exciting in the long term. And I don't think anyone's going to do it better than Tesla, not by a long shot. Boston Dynamics is impressive, but their robot lacks a brain. And then you also need to be able to design the humanoid robot, in such a way that it can be mass manufactured. And then at some point, the robots will manufacture the robots.